Hello, class. We're going to talk about our next topic today, which is work. This is for assignment A. And what we're looking at is how you look at work. And there's two equations we need to use for this problem. Set one is that force is equal to mass times acceleration, which we learned earlier. But work is actually force times distance times the cosine of theta, which that cosine theta is the angle between the horizontal and how you're pulling it. Because if you're pulling something in one direction, that's the work that's being done. If you kind of do it in two directions, the amount of force in one direction, in the opposite direction, or actually in the perpendicular direction, does not count. So that's where the cosine comes in. But we're looking at basically combining those two together, and we'll get to that in a minute. So let's look at this problem, our example problem. We got this tower in Chicago. It's supposed to be the tallest apartment building in the US, totally apartments. So if you take the elevator from the street level to the roof, and it goes the entire distance at constant speed, and it does 1.15 times 10 to the 5th joules of work. So if we look at this is now our value for work. And as you look at the entire distance, the mass is 60 kilograms. We're looking for how tall the building is. And we're looking at the work on us. So this is work on me or you as we're going up the building. So if we kind of do a little drawing, sometimes drawings help. Here's the apartment building, here's the elevator, and there's you. And we're being lifted up, and it's taking 1.15 times 10 to the 5th joules of work to do that. Now, what's acting down, remember, this is at constant velocity, so the acceleration going up and the acceleration going down are equal, and this we know is gravity, which is 9.81 meters per second squared. And that's going to be a constant. We're given the mass, which is, if we go back up here, is 60 kilos. And this is equal to work. Now, let's go ahead and look. So here's the drawing. And sometimes it's nice to do a drawing. I know a lot of people don't like to do drawings because they want to get this thing done as soon as possible. But if you're having trouble, just kind of draw it out and figure out what is happening with all the forces. So we have work. 1.15 times 10 to the 5th. And let me double check that number. Yep. And the mass is 60 kilograms. And no conversion here. And then we have acceleration of gravity. That's 9.81 meters per second squared. Now, our equations that we're working for, F is equal to ma. And then we have work is equal to force times distance times the cosine of theta. Now, here's the thing. Let's go back up to this drawing. You in the elevator is going up. The work that we have is going up. So all the force is being pulled on the body going up, and there is something going down, but then again, the acceleration, these two are going to be equal to each other because velocity is constant. There's no change in velocity. So, theta is equal to 0, which means that the cosine of theta is equal to 1. So now work is equal to F times D. But F is also ma, so work is equal to mass times acceleration times distance. Now we've got something to deal with. We're looking for distance. We have mass, we have acceleration, and we have work. So divide both sides by ma. So that, I'll come over here. Let's go down here. Work over mass times acceleration is equal to distance, because these two cancel. So here we go. 1.15 times 10 to the 5th over 60.0 times 9.81. And that should equal to the distance we travel from the ground floor all the way up to the top. So if we do the calculation, 1.15 times 10 to the 5th divided by the quantity, and that's going to be 60 times 9.81. We are going to have a distance that is equal to 195 meters. I'm going to keep it to 3 digits only. Now, let's look at the units. Joules is the same thing as meter squared over second squared times kilogram. So that's up top, second squared times kilogram. Now, we're dividing by meters per second squared times kilogram. And so if we look at that, rearrange this, we got meters squared over kilogram, meter and second squared moves up on top, and then we have second squared on the bottom again. So kilogram cancels, second squares cancel, 1 meter cancels, and we just have a meter up on top. And then that's the unit, so everything works out correctly. So here's our answer. We did the unit conversion, and this is finishing the example video for unit problem set A for work.